Hi guys, welcome back to lecture 2. In this part of the lecture, I'm going to do some hands-on using R. So what I have done, I have essentially put all the data in a vector y, and then I rate that data as kind of a matrix and put, so you can see the data here as a matrix with 4 rows and by row equal to false because I want to read them as a column. So now if you run that, I rate the data as a matrix and then I put the column names here. So if you put the data here, so you see the way exactly I presented in the theory part, the data is kind of looks exactly something like that. Now if I apply, if I use the apply function and to calculate the mean by columns, it will give me the group means. So if I just say data comma 2, it will give me the column wise mean, and I just call for mean. So it gives me the column means for each group. So toxin 1 has a group mean of 23, toxin 2 has a group mean of 33, toxin 3 has a group mean of 20, and control group has average of 13. Now what I'm going to do, I am going to apply the model equal to say mod lm, and okay, before that I need to define a treatment. Say treatment equal to replicate, and say first I want the first 4 values in the y variable is belongs to toxin 1. So I'm going to create toxin 1 4 variable, then next 4 observation are going to toxin 2. So I'm going to create this toxin, this is toxin 1, this is toxin 2, then I'll just copy this 2 and here this is toxin 3 and this is control group. This is control group. So let me just run this. So what I have here is toxin 1, 4 toxin 1, then 4 toxin 2, then 4 toxin 3, and then 4 toxin com. Now what I'm going to do is if I just cbind dot data dot frame comma y equal to dot treatment as a df, I'm going to keep that as a data frame. Okay, now if I just run the data frame, so you can see that my y variable is all the values that we have in the data and treatment, which group this particular value belongs to. The first value belongs to group toxin 1, second value belongs to group toxin 1, toxin 1, toxin 1. Then fifth value belongs to toxin group 2, sixth value belongs to toxin group 2. Similarly, the eighth value belongs to toxin group 2. Then the ninth value belongs to toxin group 3. That's how I am pre-processing the data. Now I'm going to fit a model using lm, saying that y colon treatment 1 data equal to df. This df I'm going to give, so this gives me model, and if I just run this, it gives me the coefficient values, but I will come back to this. Before that, So first what I'm going to do, I'm going to from the model, I'm going to extract the model matrix. Model dot matrix and as the X or design matrix. Now you will see, if you look into this, first is intercept, then the second column is treatment toxin 1, then treatment toxin 2 and treatment toxin 3. Let me just increase the font window size and run this. You can see this is the exact design matrix that we got in the theory we designed, and this is exactly what we are getting. Now what we are going to do, I am going to compute the beta hat. Before that I need to compute the X transpose X, percentage star percentage X. So this is my X transpose X. This is exactly what we got, 16 4 4 4. So let me see if I can. Yeah, this is exactly the X transpose X we got. And then we solve this. This is exactly what X transpose X inverse we got. X. Then we get X transpose, multiply it with X transpose X transpose Y. So this is exactly the beta hat that we got. So let me see, beta hat. This is exactly the beta hat we got in our previous method. Okay. Now what we will do from the, we fit the model here. Remember that. So from the model we will extract the coefficient and we also have the beta hat. So we will just bind them. So you can see that LM is also using the same method. So our coefficient from the LM and our calculation exactly matches. So now you understand that in the categorical variable, when you use categorical variable as predictor in your regression model, you have to sacrifice one of the level out of many levels. First of all, you have to have at least one level, more than one level, and you have to, if you have 4 levels, you have to at least sacrifice one of the label to make the design matrix full rank. That is very important, and if you don't do that, then, and if you create dummy variable or the one-hot encoding for all of the level, then your matrix will automatically become less than full rank, and you will not have a solution for your coefficients. So you have to be careful when you are creating the dummy variables.